This is an explanation on how Euler's method works. So the idea is you're given a differential equation, so y prime equals f of x comma y, and you're also given, this is an initial value problem, so you have y at x sub 0 is equal to y sub 0, and you're given a step size that's delta x, sometimes it's written as h. So the idea here is you kind of just follow the direction field. So we've got on this graph, we've got x sub 0, we got y sub 0, we got the point at x sub 0, y sub 0. At this point, we have this y prime equals f of x comma y. If we plug in x naught and y naught, we get some sort of slope. So let's say that slope is, that. So the idea then is we're going to take the slope there, we're going to follow along that slope line, and we're going to keep doing that until we get to the next point here. So let's see, I'll call this x1. And so the difference between x1 and x0 is delta x. So I do have to extend my line up a little bit. So something like that. All right. So this new point is also the value of y1. All right, and then we keep doing that over and over again. So we start at a point, we now evaluate the slope field at this point again, the direction field. And right, we get that because we now have x1 and y1. We can plug that into this f function. That gives us y prime, that gives us the slope. Let's say that's a little bit steeper, right? And we're still going to go forward a certain amount. So from here to there, that's about the same distance. It's supposed to be delta x again. And then this is going to be x2. And then it looks like I didn't extend it quite far enough, something like that. And that one's going to be y2. And you keep doing this over and over again. So let's say this time it had a slightly negative slope. So I'm going to write out this first. So this is going to be x3. Again, the difference between x2 and x3 is delta x. And then let's say this one had a slightly negative slope, and that's approximately right above x3. And this point would actually be y3. You do that, and you just keep doing that over and over again. So let's say I get x4, x5, x6. And so let's say it turns out to be, a little bit up in this one from x3 to x4. Then it turns out to go down quite a lot, so that's going to get to x5 and y sub 5, and then maybe it just flattens out here, and that gets to x6. So the idea is if you make these delta x's much smaller, you don't get such a crude looking curve, you actually get something that might actually look like the actual solution. And so the way we calculate these lines is, right, we start with x0 and y0, right? To get to x next, x new, that's going to be x old, x previous, plus delta x. And so to get, x1 is equal to x sub 0 plus delta x. x2 is equal to x sub 1 plus delta x. Right, so on and so forth. X3 is equal to x sub 2 plus delta x. So you just keep incrementing by delta x. The y one's a little different, so the y new, y next, is going to equal the starting value, y old. So this point, we started somewhere, and we want to add the change in y. Okay, well, how do we get the change in y? Well, we've got a couple things here. We have this delta x, and we have this function f of x comma y. So to do that, it's going to be, y old plus, I can change this a little bit. I can write change in x, and then I can have a fraction. This will be change in y over change in x. So to do that, it's y old plus the change in x that we're going to be using is delta x. And that's going to be multiplying, this is the slope, the change in y per change in x. So we're going to use f of x, and it's going to be x old, x previous, comma y old. Right, so we take the old value of y, and we have it go up or down a certain amount, and it's going to follow the slope, and it's going to go to the right by delta x, and that's how we get these new points every time. x sub 0 to x sub 1, x sub 1, x sub 2, x sub 2, x sub 3. In each of those times, we just follow the slope line until we get to the next x sub 1, x sub 2, right, this line is longer, but the distance between this dot and this dot is the same horizontally. And that's the idea. So now we're going to do some examples, and the first one's going to be fairly intuitive on why this works. And if you learn to do this, if you can do this 3 times, you can do this 1,000 times. It's the same procedure over and over again for every single increment from y sub n to y sub n plus 1.